So today we're going back to my roots as a collector. Antique radios. Here we have an RCA Victor Model 120. This radio was introduced as a competitor to the Philco Model 80 family. The Philco Model 80 was a 4-tube super regenerative receiver that was introduced near the beginning of the Great Depression. It was a low tube count receiver built as cheaply as possible, yet still performing fairly well. RCA, not wanting to stoop to a super regenerative circuit, used their conventional superheterodyne with a slightly higher tube count and built this, which is a slightly more refined product than the Philco it was designed to compete with. It may have also been slightly more expensive. At any rate, we're going to do a resurrection on this radio. This is an AM shortwave capable receiver. They made versions of this radio without the band switch knob, as I understand it, that were AM only. Same way the Philco 80 family had shortwave and non-shortwave models. We're going to start the radio off at around 30 volts. It's drawing around 8 watts right now. Now you may notice this tube lying here. Since there was a radio swap meet today, yesterday I went through and I tested all the tubes in the radio. A number of them aren't performing very strong, but the 2A5 audio output in this radio, I believe it's lost most of its vacuum. The heater in this tube is supposed to be a 2.5 volt heater, and I had to crank it up to around 5 volts to get normal heater brightness out of the tube, and I couldn't get any emission out of it no matter how hard I tried, so I'm pretty sure this tube is full of gas. I also played around with some other switch settings and was able to, I think, switch the plate for the screen grid and get the center of the tube to light up a nice gassy purple color. An interesting thing about this tube that was in this radio is, and it says J&R Motor Supply Co. and RCA radio tubes. So I wonder if RCA in 1938, when this was sold, or around that time period, actually rebadged certain tubes for certain companies. It's an interesting part of this radio's history at any rate. So the wattage has come down to 6.9 watts. I'm going to increase the variac by 10 volts. The wattage briefly spiked to 7.2 watts and is down to a steady state 6.4 watts currently. It's slowly dropping. This radio, as can be seen by this 50s RCA Globetrotter portable line cord. I had a RCA Globetrotter portable with the same power cord as this. Clearly someone in the 50s or 60s hacked a cord off of one of those sets and replaced the original cloth power cord with this newer plastic cord. Also, this can electrolytic right here. This is an FP twist lock style can electrolytic. These didn't come along till the later 1930s. This set is early 1930s, I think. Oh, and check this out. We found us a date me code. October 10th, 1933, I believe this reads. So, this radio's power transformer was made in the same month that I came into being, many decades before then. There's a chance, given that the radio would be assembled after the power transformer was assembled, there's a chance this radio, depending upon the delay between those two, might have been put together on my birthday. That's kind of cool. And it predated the FP twist lock cans. So someone worked on this set probably in the 50s or 60s would be my guess, based on the power cord that's been added to it and this twist lock lytic. What I can see without taking the chassis out indicates to me that this radio hasn't seen much service beyond that, other than my tube replacement yesterday. So wattage is down at 6 watts, and we're at 40 volts on the variac dial scale, and we're probably at slightly higher voltage actually being output from the variac, because the dial scale's accuracy varies both based upon the input voltage coming to it from the wall, and it's highly unlikely my wall voltage happens to be at exactly 120 volts right now. And the accuracy of this knob also varies depending upon the loading, i.e. the amount of power that's being drawn by the device plugged into it. So, given this radio is a very low load compared to what this variac is rated for. Okay, so we are at 8.1 watts of power draw at 50 volts. Input voltage, let's crank it up to 60 volts. And that's now drawing 11 watts. So this radio claims to draw 75 watts in normal operation. Okay. Can't see any of the tubes lighting. Does this thing have a dial light? I tend to think not, but... Oh, no, there's a bulb in there. Oh, and I see it. It's faintly glowing. Good. That tells us at least one winding of the filament transformer is still good. Let's crank it up. Steady state 11 watts, that's fine. Let's crank it up to 70 volts. That's 15.2. 15.1. Still dropping. What's the voltage? 70 volts on the money. Nice. I'm just gonna let that wattage settle out a little bit. That reminds me, I should have the basement long wire antenna ready in case this radio starts to come to life. It's been worked on recently enough to have a fighting chance. If this had the original 1930s electrolytics in it, I wouldn't expect it to work at all. Most radios, RCA, Philco, various brands back in this time, had what were known as wet electrolytics. Essentially, it was a big, empty metal can the size of this that would have a single positive electrode that was basically like a 1/4 inch wide strip of metal tape, essentially, that was hanging in the center of the can that would be immersed in electrolyte. Those would generally leak out their electrolyte over time and or have the electrolyte evaporate. Even well-sealed ones after 80, 90 years, yeah, they're bone dry. And when they go bone dry, they stop really being electrolytic capacitors, and their capacitance goes from around 4 to 8 microfarads original value down to picofarad capacitance that doesn't do anything. So we're just going to be foolishly optimistic. And here, I believe, is the antenna leads. We'll just clip our little basement long wire onto that. I think this is the ground, the antenna ground. These sets generally didn't have power ground on them. Let's increase the voltage to 80 volts. That's now drawing 20 watts. Power rectifier tube's warm. You can see glow from a couple of the different signal tubes in the set. The dial light is gradually getting brighter. The electrolytic is stone cold. That's good. And we're only drawing 19 watts out of the 75 that it's rated for. Let's turn it up to 90 volts. Hello. We have sound. Okay, so this is tone, this is dolphin, or is it chipmunk? No, it's definitely annoyed mouse. Warbler? That's poor filtering and audio load from the audio circuit causing dips in the RF system that cause the RF to oscillate, I think. Sounds like it's trying to get something from the RF. I don't know if I'm on shortwave or broadcast. Let's try the other band. Wonder how much of that I actually got. So we got it up to 100 volts. We've got motorboating at high volume. Squeaky motorboating. So it motorboats differently on different bands. Power draw is still consistent. Let's crank it up to 110. This thing's rated for 115 normal operation, so we'll say that that's about the most that we reasonably should put onto it with iffy original capacitors inside. The choppers are coming! The choppers are coming! That's some epic motorboating. That's definitely tone. We told them chipmunks not to escape. Yeah, it's like video game noises. So, electrolytics still have some life left in them. The humming isn't excessive, but clearly there's problems. My guess is bad coupling and bypass capacitors in the RF stages on this thing are probably causing it to make all of those space noises. Well, now we know it definitely needs a recap. And there's clearly evidence that the RF stages are trying to work, and that the audio stage is working. Let's switch the variac off and unplug this. And I'm going to switch it back to a cloth power cord and a period correct style plug, because I need a power cord with a plug like this for my Dumont Manchu, and I think this is the only cord I've got like this that isn't on a piece of equipment that it would be original to. So, we'll kill two birds with one stone. We'll get a period correct power cord for the Dumont, and we'll get it by putting this back to a period correct power cord from the whatever the hell someone installed on it power cord. I just get all the knobs off, dial all the set screws to pointing straight up, grab the world's longest small flat edge screwdriver. Ooh, these have flats on the knob shafts. That'll make getting them lined back up correctly easier. I'm going to put these knobs over on my Philco 116. That should keep them out of harm's way. Based on how this set feels, I do believe that the set screws on the knobs and the knobs themselves are the only thing that was retaining the chassis, and That is a highly correct assumption. This clearly got the lazy service tech chassis bolt delete. So, one thing that I could see and I couldn't easily get the camera in to show you guys is these are definitely paper capacitors here, and those should go. At least if I want this radio to be regularly usable. That's another paper capacitor. This is one. That's one. That's one. Wow. This is neat. This is someone's early 30s era capacitor replacement right here. This is an Illinois capacitor, or actually an Illinois condenser brand capacitor. I think that company is still in business under the Illinois Capacitor brand. This is one of the oldest I've seen. This had to have been very soon after the radio was made. They didn't make this paper style with the paper mounting tabs past maybe 1934. This is neat. And this is, it claims to be a dry electrolytic. That's interesting. Most I've seen in this particular casing style, even the high microfarad ones, were paper capacitors. So they use this case for both paper and electrolytic. That's cool. Needs to go, but it's cool. They tacked it in replacement of this big capacitor back here. This big capacitor I think might be a multi-section electrolytic. And they tacked in this capacitor to replace a section of it. I'm kind of surprised that this is here and nerding out about it. Also, I'm pretty sure the company that made it, Illinois Condenser Company, is still in business. And when we exited the Stone Age and stopped calling capacitors condensers, I'm looking at you, points ignition car people. I'm looking at you, grease monkeys with distributor ignition systems. All these capacitors, aside from this one replacement, are unlabeled as to their value, so I'm going to have to look up the schematic to figure these out by finding them in the wiring diagram and looking up their values. That'll be fun. So I rounded up the capacitors that are called out on the schematic. I'm going to recap this set completely because all the capacitors are ancient and I don't trust them. I'm going to start off by desoldering this capacitor here and checking it on my Heathkit C3. This capacitor goes from one of the pins on the 2A7 to ground, and looking at the schematic, and checking pins that go from it to, and checking capacitors that go from pins on this tube here to ground, the cathode right here has C9, which is a 0.1 microfarad that goes to ground, and that seems to be the only likely candidate to be that capacitor. So we're going to assume that's C9, and we're going to check it in a minute. Okay, we got that cap unhooked. It's testing at about 0.1 microfarads capacitance, which is right on what I expected it to be. Let's check leakage. It's kind of leaky at 350 volts and also at 450 volts on this tester. So definitely a replace. And by testing the actual capacitance in addition to testing for leakage, we also verify that the capacitor is what we think it is. Now I could try restuffing these capacitors, but honestly, I think these old school RCA paper capacitors that have no printing other than a generic meaningless part number are actually pretty ugly. And these aren't very big and aren't very obvious, so I'm going to recap it with modern capacitors as cleanly as I can. This 80-watt welder is pretty good for making chassis solder joints. That's right. You know, I need this chassis to be upside down to make that joint good. Nothing makes you feel good about the condition of a radio like turning it upside down and having a dog bone resistor randomly drop out. This thing looks like it was clipped out. Where was this and why was it sitting inside this radio? Well, we'll just pretend we didn't see that. So that's a good solid solder joint right there. So let's power this RCA up real fast and see what it does. Start out at 30. Clip onto the antenna real quick so that we have an antenna. Probably get lots of noise from the PC, but that's what it's going to be. Okay, that did not help with the motor boating significantly. Let's pick another capacitor to go after. Okay, so the next cap we're going to address is C26 right here, a 0.01 microfarad that goes between the cathode of the audio output tube and the grid, and we're going to try to focus on capacitors around the audio output tube right now to see if any of that is an audio stage oscillation, if any of that chirping and motor boating is an audio stage oscillation. It could be RF stage, it could also be audio stage. It occurs to me that's a good place to start, both because the audio output stage caps are some of the easiest to reach if the chassis is turned on its other side like this, and because the audio output tube that was in the set when I got it was bad, so it's possible that tube was driven to failure by bad paper caps on the audio output stage. So we'll address those first to help save on the audio output tube in case it is in trouble from those caps. And then we'll start diving into filter capacitors and the other paper capacitors in this radio. So we have us some genuine rat's nest right here. Look at this capacitor. It comes off one lead of the audio output tube, goes to this floating joint between two dog bone style resistors. One goes to ground, the other goes to another terminal of the tube. This is what they did back then. It's very cringeworthy, but it's what radio manufacturers did back then. This is original soldering and original workmanship. So we got a lead on that cap lifted. Let's just hook our meter up to it, and let's find out if this capacitor is a 0.1 the way the schematic indicates that it should be. Well, that's great. This capacitor tester is telling me this capacitor is over 1,000 microfarads, which is impossible for a paper capacitor. So I'm going to guess this capacitor has very bad leakage. Let's find out. Oh yeah, it's leaky at 50 volts very badly, and it's leaky at 150 volts even worse. Yeah, that cap's done. It's toast. Complete toast. Glad I didn't run it very long with that capacitor in there. Now I gotta figure out how to even reach that solder joint. If you thought predicted tandem repair was ship in a bottle stuff, I got news for you. Some antique radio repair is just as bad, if not worse, even on point-to-point stuff. Sometimes they just wired things in so dense that you can't readily get into position to work on it. Look at what my camera's pointing at right now. Oh yeah, I wasn't even pointing at the joint that I was soldering on. That's great. So you guys didn't get to see any of me soldering this capacitor in here. Well, it's in the new 0.1. Let's plug the audio output tube back in, seeing as how we unplugged it a moment ago to help sneaking the soldering iron in there. Let's just plug it back in and plug the radio back in and crank the variac up and try to get a okay, I may have lost the demonstration of this radio to my camera, spontaneously stopping recording, and then not restarting recording. 2 different times I pressed the damn record button. Nikon, you guys build a real piece of camera. It's a real piece of something. So, this other cap that also connects to the cathode, similar to the one I just tested, it is C27 8.025 microfarad. And that one seems to be a little bit soft and slightly warmish from test running the set, so we're going to replace it with a 0.22 cap. Okay, we just deleted on this old, ugly, non-rebuildable, I think cathode feedback cap off the audio output tube that tested poorly. Let's power this radio up and see what it does with that cap changed. Okay, we're still getting oscillations and laser noises and dying dog noises. Okay, well, let's move on to the next cap. Let's change out the one that most badly needs to be dealt with. C25, the 0.01, I think, microfarad capacitor tube. Yeah, capacitor tube. I'm clearly not very awake. Ah, it's a 0.02 microfarad. So as I was saying, we're going to replace C25, the 0.02 microfarad DC blocking capacitor between the grid of the audio output tube and the plate of the first amplifier tube. That one's pretty deeply buried in the rat's nest. So how do I get down in there? Is this the lead for it? Yeah. Wow. That is buried. Okay, so we replaced the coupling capacitor / DC blocking capacitor for the audio output tube. So now all of the audio output stage capacitors have been changed in this radio. Well, aside from a couple of tone caps on the transformer, but those aren't going to cause the motor boating we've been seeing. I suspect the motor boating is probably in the RF-IF system of this set, most likely the IF, because it would be higher gain and more prone to oscillations. I got a progressive rock station. Cool. No, just more motorboating. This is a test of the emergency broadcast system. No. Okay. So that didn't work. Well, we're going to continue the recap on this. Mostly because this thing is such a rat's nest of thickly layered parts that I'm not able to really tackle, or that my decision to tackle capacitors in this radio is more based on what I can get access to and what opens access up to other things more so than what I think is going to fix the problem. Okay, so this capacitor is easy enough to get at. The diagram claims that's C17. Wish these nostalgia era writer's manuals were scanned in a resolution that made the fine print that most of the text is inhumanly readable. This thing's illegible. We're just gonna unsolder a leg and test it. If the layout is correct, it's a 0.05 microfarad cap. I don't know how much of that we got. We just replaced a 0.0. I'm sorry, I have to unsolder it the rest of the way before I can claim I've replaced it, even though there's a new cap already in circuit. Let's delete the old one. I've replaced what I believe is C17, a 0.05 microfarad capacitor. There's a wiring diagram, there's a chassis wiring diagram for this set, and I replaced the cap based on reading the chassis wiring diagram because with what a rat's nest it is, everything this cap connects to aside from chassis ground is confusing enough to make it hard for me to ascertain where the cap is in the schematic. In fact, the schematic's part identifiers are so poorly scanned by the people who scanned the writer's perpetual troubleshooter schematics years ago that I can't read any of the fine print that specifies this capacitor's ID number. I put in a 600 volt cap. There's no way there's going to be 600 volts or higher anywhere in this radio. Paper caps, these radios generally aren't picky about what you put in for paper caps, so okay, symptoms are still about the same, so let's keep looking stuff up. The tone control has a switch on it. It also has a 2-terminal condenser on it. That's interesting. That might potentially give us some 2-for-1 component replacement. Yeah, maybe I will do that. It's supposed to be 0.033 and it's 0.055. Okay, so they're across the power transformer like that. So the 0.035 goes from the wiper of the control to the same point that the other one goes. Okay. There is no wiper. Panic.
What do you mean cut the blue wire? They're all blue wires.
The wiper only goes to the cap. So the terminal that only goes to a cap is the 0.035. So we'll use the 0.033 for that. And for the 0.005, we'll use the 0.047. Okay, we're going to quick test the tone capacitor. It's a dual section paper capacitor. An odd thing that really fell out of favor by the mid-30s. Let's see here if we get any eye opening. Not really. That cap's just about open in terms of capacitance. Well, it's electrically shorted or very leaky. So, yeah, that one's shot. Let's just start wiring our replacement in. Can't see nothing. It occurs to me I never moved the camera, so you probably can't see nothing either. This is exciting like drying paint, so I'm sure I can assure you you're not missing anything glamorous. It's me fighting in a tiny little crevice that I couldn't film if I wanted to. With a component lead that's older than dirt. Okay, tone cap's changed. Doubt it's going to change anything in terms of this radio's performance, but let's find out anyway. Dial light's getting a bit brighter. We still have noise scanning through the band as though we have reception, which is interesting. Supposedly, if the parts list is correct, we only have 5 more paper capacitors in this thing. Only 2 of which are actually visible to me. And I question the existence of the other capacitors. So, the next remaining paper capacitor comes off the wiper of the volume control, and the wiring diagram claims it is a 0.05, I think? C13? That could be. Yeah, I'd buy that. Okay, since that's the easiest paper cap to get at right now, let's desolder it. What doth the Heath kit say? We've got ever the slightest capacitance, high in value. What's the leakage? Leakage at 50 volts is pretty atrocious, and at 150 it's still pretty atrocious, so yeah, this thing's just full of leaky bad old capacitors. How do I even get at the solder point for this one? I guess I slip my soldering iron into this narrow crevasse and use my sixth sense and pray that my sixth sense is accurate. There we are. Okay. Okay, so we're going to just solder that in a what? Okay, so I have 5% battery life. Big whoop, you want to fight about it?
So you got a tank. Big whoop. Want to fight about it?
Okay, we got the paper cap on the volume control changed out. That was the last easy paper cap, and one of the last two that I know where to visually spot. Let's crank the voltage up on this thing, and let's actually, don't turn it off yet, Tom. There's a... So, I've got some goofy ideas for some tests here that I can do while I'm on this. So, I want to just try bridging the electrolytics. But first, I have to figure out what the heck polarity the lytics even are. Let's guess negative. And positive? Yeah, 243 volts B plus. That seems like a little bit on the low side, but odds are the original electrolytics are a bit leaky anyway, so. Ooh, that quieted it down quite a bit. Well, that's a litany of interesting noises. Now I understand that that filter cap isn't a major thing with this Well, it clearly is something that does need to be dealt with in the near future. Another thing I noticed is it seems like both the main terminals of the old cap have been cut off, so I am going to unmount the old capacitor from the chassis because it is very big and bulky and it gets in the way of servicing other things that are here. And for those people who really like to see capacitors get restuffed, I'm not going to do that, but I will meet you halfway. I'm going to keep the old capacitor carton around so that in the future, if someone with more motivation to do such a thing than myself ends up owning this radio, they can do it. Oh. Wow. So there's other capacitors in here. Well, that's bizarre. I just opened a can of worms. Now I have to figure out where all of these different capacitors go. Well, first off, let's undo this guy. Okay, so we removed this big electrolytic capacitor. Now it had a negative terminal on this end and a positive terminal, this metal terminal here. Initially I thought that was all there was to it. It had a newer-ish 8 micro tacked in parallel, and these two leads cut off by a previous repair person. While removing it, I noticed there are 3 more leads sticking out of it. According to the parts list on the schematic, there is a capacitor assembly comprising 3 4 microfarad capacitors and 1 10 microfarad capacitor. I'm pretty sure the 2 standalone terminals are the 10 microfarad, and I think these 3 are the positives of the 4 microfarad capacitors. Since both terminals were lopped off, effectively all of the 4 microfarad capacitors were disconnected from circuit, which I'm sure is doing the radio lots of good. Wires I lopped off, I soldered onto terminals on this terminal strip here. And what I'm going to do is, I'm assuming these are the positives of the 4 microfarad filter sections. I'm going to power up the radio and do voltage checks on those 3 terminals on the newly installed strip that those wires go to. And if those wires have positive voltages on them, I will conclude that they are indeed the positives of the 4 microfarads. If I get the 4 and the 10 microfarads mixed up, it's not going to be the end of the world. It'll just mean extra filtering in some places and insufficient filtering in others. Honestly, radios of this time period tended to have borderline insufficient filtering anyway, so slight increases or decreases aren't going to hurt the set that much. Okay, first terminal. First terminal, positive 86 volts. Second terminal, positive 4 volts. Third terminal, 130 volts. Okay. Good enough for me to be comfortable sticking capacitors onto those terminals. Now we have got all but 1 electrolytic capacitor replaced and 4 of the paper capacitors. Let's hook this thing up and See what it does. A lot less hum now. Holy crap, there's some audio.
Victory for the Nuggets. Keyshawn, J. Will, and Max. You're in love with Herbert. You're infatuated with Herbert. I think about him every morning. Most days I think about Justin Herbert. More from the guys Wednesday morning starting at 6 Eastern on ESPN Radio and ESPN. We've been representing business.
Okay, so there are, according to the schematic, 4 paper caps left in this radio. I can see 3 of them.
Deserve good lawyers. But investment shows. What do you think the percentages are? Take Icky. You said earlier, when I threw out there, the expectation should be to make.
Seems to be working okay.
Buried in the end. That's a good thing.
Yeah.
There's some shortwave action. We had AM before I adjusted the band switch here.
Thank you. Okay, we'll take a break. We're going to come back. We have a line. Actually, just opened up a line right there. So if you want to call in, if you call now, you won't get a busy signal. 888-914-9149. 888-914-91.
Here's an interesting question. Oh. The shortwave on this unit, I think, also includes the extended AM broadcast band. Basically, the AM broadcast band until sometime in the 70s or 80s only extended up to around 1500 kilohertz, and they extended it to 1750 around the 70s or 80s, somewhere in there, if I recall correctly. Prior to that, some radios had what is now the extended AM band's top half in a shortwave band. So this one includes the extended AM broadcast band and some stuff that is still considered shortwave today.
Hello, I'm Father James. Thank you, Director of St. Francis Mission in West.
So now we have the radio basically working. And now let me tell you about this week's sponsor. Beat 1920s headphones. You need Beat 1920s headphones in your life. They have so many uses. Use them with your car phone. That should do it. Perfect. We're ready to make hands-free calls. Or add a classic 20s free dialer AM receiver to turn them into wireless headphones. And their stylish design looks good on anyone. I think I just got ghost lice. Order now and we'll include this stylish double XL coat pocket sized carrying case. Only free easy payments of 1 gold Buffalo Walking Liberty nickel. Order today. Now that the joke's over, we begin the rest of our episode. Let's change the remaining paper capacitors, at least the ones that we can find. The mysterious 4th capacitor, I'm not sure where it's located. There's a capacitor here, And it's right around where the band switch is, and it doesn't show it clearly in the wiring diagram. At least I don't think it does. Maybe it does. Let's grab a lamp and see if we can comprehend this. Oh, and you know, one lead of this capacitor soldered to ground, so if I just desolder that, like so, I can trace where this capacitor goes. Okay, it goes to that tube, and that tube is the type 58, which I think is an RF amplifier? Yeah, it would go to the RF amplifier tube. What other interesting, looks like it might go to two of the pins on that tube at once. Yeah, it goes to two of the pins on that tube at once. So, that makes this easier to look up on the schematic. So, these two pins here are the only two that are directly connected together. It looks like cathode and suppressor grid, which is pretty standard for pentodes. And I'm guessing it's C5, which is supposed to be a 0.1 microfarad. If that incredibly hazy text is correct. Let me see if I can find a C5 in here that's a 0.1. C5! Yes. RF and IF bypass. Okay. So, since we're already here, and we have the capacitor tester running, let's just hook it up and see how it tests. So it's hooked up. Let's give it a check. Let's scan around for capacitance. Okay, maximum eye opening is at around 0.2 microfarads, which is double the capacitance it should have. Leakage at 25 volts is atrocious, and at 150 it's even worse. So that cap shorted out, and that was a cathode bypass capacitor, I think. Yeah, that was the cathode bypass for the... Yeah, that's the cathode bypass for the RF amplifier tube in this radio. So that's probably making the front end perform a fair bit worse. Let's change that out for a new part. There's our last 0.1 cap. Now, how do I even get into there to get a soldering iron onto that? You know, I can't even get my dikes in there. Okay, so we got that capacitor replaced, snuck in there. It used to be that it was grounded over here, and a little terminal way down in there that you can barely see is where it attached. That terminal is so buried that I'd have to burn like 3 different wires to get a soldering iron onto it. And since that terminal is wired to an adjacent terminal directly with a wire, I can just relocate the capacitor slightly, and that puts it in a location that's serviceable without taking apart half the rest of the radio. That's literally every paper capacitor under chassis that I can find. But it's not all the paper capacitors in the radio. These two guys here and here need to go. I think this is the antenna coil, and this might be the oscillator coil. I'll do some schematic tracing in a little while to identify those capacitors, and I'll test on them and show you before I change them. But let's see if changing out the pretty much shorted cathode bypass capacitor on the RF amplifier tube perked this thing up any. It'd help if I plugged it in, wouldn't it?
Pack them in, work as tight as they can. This season, last year, this... waiting to radio. I'm also proud of the loan. And I'm also opportunities.
Like Curtis said in the video,
I'm engaged. We handle the.
or wasn't sufficient, Pope made of the thunder. The pressure of your partner, even worse.
Let's figure out what these capacitors are. Then what we'll do to finish up the work is we will replace the power cord with a period correct cloth cord instead of this plastic one that we need elsewhere. I'm going to figure out something to do about the damage on the one rubber wire to this tube's top cap lead. Those two paper capacitors need to go, obviously. I think that'll be basically it. Okay, let me get to figuring out what these capacitors are. So that coil goes to the top cap of that first 58. Two of its leads go to the antenna leads, and one goes to a capacitor and a dog bone resistor. Those are color-coded body and dot. I see no dot, so body and end would be, and assuming the dot's the same color as the body, then it would be a 2000 ohm resistor. So the antenna coil does have a 2000 resistor. It looks like it has a 0.05 microfarad capacitor C2, at least that, if I'm reading that correctly. There's a C3 that's a 0.05. We're going to guess that that squiggle on the schematic that says it was C2 is actually C3. Yeah, that's about the only recourse I've got there. Yeah, we're going to assume that's C3 and assume that the capacitance, which is slightly easier to read, is correct. Let's desolder this capacitor. Okay, my camera stopped and I don't know where it stopped. Whatever. So I've got the antenna coil capacitor that I believe based on the schematic is C3, a 0.05 microfarad capacitor. Schematically, I think I see the part. The only problem is the schematic print is so fine that the crappy resolution the people who scanned this to the internet used makes the text illegible. So we're going to test the value of this capacitor to see if... And we're burning the workbench with the soldering iron resting on it. That's great. So the capacitor is barely opening the ion capacitance test, and it's testing around 0.1, around double what its value should be. So I'm pretty sure it would be a 0.05. What are you flipping out for? Quit it. Leakage test. It's bad at 25 and it's worse at 150. That tells me all I really need to know. I convinced it to come loose. Now I need to solder a new capacitor in. The can's probably aluminum, so I can't solder directly to the can. The good news is that the leads of the capacitor are probably long enough to allow me to get it to reach the two mounting, to reach the two solder points that the original capacitor was connected to, one of which is a chassis ground, which I could relocate if I had to, but I don't have to, so I'm not going to. Moment where you need a straight edge screwdriver to fit into a tight little gap that you wouldn't normally fit a straight edge screwdriver into, for the reasons that... whatever. Let's just get it soldered in. Okay. Yeah, that's soldered in solid, and it looks like a good solder joint. So let's see how it performs with the antenna capacitor replaced.
Accept this out with confident love. With grant that war duration in a terrific defensive outfielder. Start out. Move and you can return. It's a mile high.
After a base. Payment plan. You know.
Pattern. Go Browns.
Looks like this radio would like both an antenna and a ground.
Ignored by the rest of the media because formed voters are the pillars of democracy. The election 2022 on News Talk 1130 WISN.
Oh, nice.
Rise up.
Do you have the right partners in place to help you?
Maybe Braxton Berrio?
Jackson's it.
You're the top tour managers in the business. With Colette, all the details, flights, meals, hotels, sightseeing, local experiences.
Okay, let's get the next capacitor. Okay, hopefully we didn't wreck any of the recordings when the camera completely froze up its operating system. And we had to pull the battery to reset it. Okay, so the only remaining paper capacitor on this radio that I can find is this one right here that is on what I believe is the oscillator coil. The only problem we have is that this capacitor is not marked, and I can't read the incredibly low resolution schematic scan well enough to identify what it is. Based on the capacitors that we didn't use from the parts list, it's either a 0.05 or a 0.008. Based on size, I believe it's a 0.05. We're going to verify that by desoldering it. Come on, don't make a liar out of me now. There we go. We're going to desolder it, and we are going to test its capacitance and try to figure out what it is. I is barely opening at around 0.7, so it's probably I should say around 0.07, so it's probably a 0.05 that's drifted off value because age. It's got some leakage at 25, it's got a lot of leakage at 150 volts, so it's definitely a bad capacitor. Might not have enough voltage on it for that leakage to matter, but we're still going to change it. You know, rather than mess with the lead dress on fragile cloth-covered antenna wires, I'm just going to cut it off because I know it was soldered to the ground on the chassis, and ground the capacitor to a different ground point. Yeah, that should hide it pretty well from the casual viewer looking in from the back. Oh yeah, that's a pretty good lead blob. Oh yeah, that feels like a solid connection. Somewhere under chassis on this radio there may be lurking a 0.008 microfarad paper capacitor that I haven't been able to find. I can't spot it from any conceivable angle. There are some extra layers of stuff. The schematic doesn't give me any good clue as to where the thing actually is. Rather than take apart the chassis of this set needlessly and potentially damage much harder to find components, what I'm going to do is just pretend like I've changed all the capacitors, because effectively I have, and see how it does. So, an interesting quirk of this radio is, according to the schematic, the antenna wire is actually the black wire, and the ground wire is actually the tan wire there's actually an explanation of what the original color of it was. Yellow. This was originally supposed to be yellow. It's now kind of a tan color. That's opposite of normal antenna wiring color code convention on radios of this time period. It's kind of interesting that RCA did that. Yeah, we'll power it up one more time to confirm it's working properly. And then we'll do a couple of brief wiring tidy-ups. Find some chassis bolts in our bins of associated odds and ends and see if we can...
We have a chance for more rain on Thursday. It could mix with a few snowflakes at times. High of 40. Additional rain is average.
50s. I'm WLKY meteorologist.
Did sit in the dirt in the left. We argument.
Site engineer. Side here. Solutions.
He's going to be opposite, or play opposite Jalen Waddle. He's going to receive and catch passes from Tua Tagovailoa. And we'll talk about Tua Tagovailoa. About Tua Tagovailoa being able to even get the ball downfield.
Sports news! Okay, so we might have lost some of the demonstration of this with the last paper capacitor that I can find in it replaced. According to the schematic, there's still a paper capacitor in this thing somewhere that I can't find, but again, it's going to be under the IF cans here, if it's anywhere, and I can peek in behind them and I don't see anything. I don't want to unbolt them and remove them to get access to it if it does exist under there, because I don't want to damage these probably unobtainium IF coil cans on this radio. We'll assume that it'll all be fine. It should be, really. So, what we're gonna do first is, we've got this plate cap here. The wire is frayed up near the connector there. The lower part of the wire is okay, and I think I can uncrimp the little connector that grabs onto the insulation, and if I can do that, what I can follow up by doing is I can follow up by desoldering the lead from the connector, putting a little bit of heat shrink over the wire right here, and resoldering the connector. Now I could replace the entire length of wire, but most of the wire isn't coming apart right now, and it's original green rubber wire, and I don't have anything that readily matches its patina, so we're gonna just do that and then find some heat shrink. I briefly considered using liquid electrical tape, but nah. This is a job for real honest to God heat shrink tubing. Okay, that's a pretty decent length. It hasn't cracked down there yet. It's still supple at the chassis grommet, so we'll leave that alone. And discover that our lighter is a few ounces of lighter fluid shy of being a functioning lighter. These Zippos are great, reliable, and fixable lighters, but the lack of sealing to keep the fluid from evaporating out of existence is annoying. There. That's all the fluid it needs, and then about another 10%. And just incinerate that heat shrink tubing right onto there. You know, I should bend the prongs open just a little bit more so this goes in and solders cleaner. Oh, I see, it solders on top. That's kinda neat. Oh, and one of the crimp pins snapped off. That's good. Well, no one's gonna see that, so except for the people who watch this video when it comes out. And if I ever sell this radio, odds are whoever it is who bought it from me will see this and go, "You hack, you!" That could be. There's more original parts of the radio being used by me doing that fix that way, so I'm content with it being just a pinch hacky. That's fine. Okay. Next up, let's do something about the power cord. Oh, and my heat kit is not necessary for the rest of this procedure. Let's disturb half the bench in the process of cleaning it up. That's fine. Come on now. Loop in there. This might make the handle slightly less convenient to grab, but it is a great way of bundling power cords and test leads out of harm's way. One reproduction black cloth power cord. I think this is a reproduction. Ooh, this is original rubber. If this is a reproduction, it's using exact original materials. Wow. This is either a perfect original or it's a perfect reproduction. Cloth covered power cord. That's cool. I've got a second one of these. I'm going to have to save that one for something extra special. This is almost too good for this radio, but I'm going to use it anyway. I think I do have a few original cloth-covered power cords that are vintage and kind of so-so. I could use those, but it's going to be more delicate using something vintage like that. So I have no clue when the camera stopped again. So I was nerding out over this vintage repop power cord I got at a swap meet at some point in time. I think it's reproduction. It might be original. It's 2 layers of cloth insulation, the outer layer that you normally see, and an inner layer of cloth. And the inner layer of cloth underneath it is actual. This feels like real rubber underneath. So this is either an original power cord or it's a really, really accurate reproduction. Most reproductions I see are just the outer cloth sleeve over a modern plastic inner wiring. This is either incredibly supple, incredibly virgin vintage wire, or it's a very good reproduction. I'm not sure which. But at any rate, I'm going to put the new power cord onto this radio. So let's turn the chassis on its head so we can get at everything easier. I'm going to try to prove that teeth aren't always the best tool to strip wire with, but they're the easiest to find. I must have used cotton fabric, because it doesn't really... Interesting. This is some really... Oh yeah, that was how they used to do that on these. I remember now. Do I have a needle? I do have a needle. So I just remembered the old classic way of doing this. I don't know if I can do it or not, but used to be... Nah, I can't make that work, so we'll just do it the modern way. What I like to do whenever I work on an old cloth power cord is I like to add about a ½ inch of heat shrink tubing over the individual line ends to keep the cloth over them from fraying, like that. And how does the old electrician's knot go? I should know this. Oh, and before I do that, so what we're gonna do is we're gonna I like to coat the individual stranded strip sections in lead. That way, when I screw them down on the screw terminals, they don't splay out like these old hanks of wire here that I'm going to have to do something about later. Okay, so my camera keeps stopping recording randomly. I already tested the knot length and fitment, and it seems to be pretty good, so we're just going to So this piece of heat shrink will keep this cloth from unraveling, these pieces will keep that cloth from unraveling. Now we can get the cord down in here like so. So the screw tightens clockwise. So we need to bend it like this. This isn't exactly the right bottom cover piece, but it is a bottom cover piece that mostly fits. Realizing it could use a bit of trimming. Yeah, that's pretty good. I got it. I got it. This is gonna be sweet. So, next up on the docket is you right here. So this is how the factory would dress the old outer insulation to get it off so it wouldn't fray. At least it wouldn't fray significantly. I'm going to try something silly with the tassel, because I don't know how they used to cut it, but okay, that doesn't really do much, but it might make it cut a little bit nicer. Yeah, look at that. Isn't that cool? So that is the right way to dress up one of these if you can find a like-new reproduction or a like-new original. Time to take the old 50s replacement off of it and burp talk, and remove electrical tape that is probably older than both of my parents by a small margin. We have this fish through the chassis eyelet. There's a nice knot here. I did that nice little thing there to do period correct stuff. I'm going to splash a little lead onto this to tin it up, and then we're going to run that wire through the same. Oh, I see. They twisted it around to reduce hum pickup. That's clever. Just there we go. So it has one twist there. Okay. That's wired in all right. I actually do want a little bit more slack inside the chassis, so we're just going to do it like that. That's pretty good. Now we got to reconcile this. I know I have friction tape somewhere. I might have to fish my Oldsmobile out of storage to get it, but I know I've got some. It would be slightly quicker to go to a hardware store and buy more, because they do still sell electrical friction tape. Warning, whenever you get tar on the tip of your soldering iron, clean it off with brass wool. If you don't have brass wool, use steel wool. If you don't have steel wool, use sandpaper. Use whatever you possibly can. Napkins, something. Because tar is very bad news for soldering iron tips. Okay. So, I think about here is long enough, probably too long. Diaphragm engaged. So I need to get some of the lead off of this so I can... Okay, now I can see how those two were originally wrapped together or supposed to be. Let's just do that. Okay, now I need friction tape. Oh, no way, I found it. It's a little bit dirty, but I found it. Well, the dirt will add to the authenticity. Okay, we will rewrap the old solder joint with newer friction tape for maximum authenticity to this clearly surprisingly newer and unaged power cord that we're adding that is period correct material. We'll just babble while we do this and not really pay attention to what we say or whether it's accurate or not. That's fine. Okay, new vintage power cord is installed. Yeah, this looks pretty good. I did a nice job with this inline Western Union splice here. Made by an actual Western Union employee of the telegraph company. Actually, it might not even have been a Western Union splice. Well, it's interesting at any rate. Let's trim that down a little bit. I'm going to put just a pinch of lead on here, just to... just because I don't want that all getting fraying. You know, we've got an antenna wire. We'll just leave the ground wire to its own devices. We know it exists. We know we can clip onto it and do stuff with it. Let's, we've got just about everything done except we need chassis bolts. Let me see what I got in the old junk bins. Seems like it might be a 1/4 fastener. This is a quarter fastener. So, why you no work? Are you quarter fine, Fred? You might be. Do I have quarter fine, Fred? To go to the hardware store tomorrow. It's a hot dog going down the hallway. You're definitely a quarter, and you're finer Fred than these guys, but you're still not working. So it won't do coarse thread, and it won't do fine thread. Now the original fasteners are long gone. I think I'm going to use the self-tapper to make the ones I do have work. This is definitely a wrong way to do it. It's a functional way, though. I suppose I could get my tap set out, but it's easier to use a self-tapping screw that's right here than find my tap kit and tap it with a tap kit. Okay, that definitely works. So we self-tappered that screw hole. I think this bolt is the same thread. Yes, it is. So since Chester Cheeto points out that I'm dangerously low on vintage quarter 20 and vintage coarse thread quarter-inch fasteners. Since the service technician that worked on this in the 50s probably would approve of what I'm about to do, and probably did the same thing on dozens of TVs and on hundreds of TVs and radios, I'm going to use only 2 chassis bolts to hold the chassis in on this. I think it'll work okay. It's gonna be what it's gonna be. Okay, took the ground wire up to the yellow color-coded ground of infinite RCA wisdom and planning skills.
Typically, we recite the Nicene Constantinopolitan Creed, which capsulizes the dogmatic formulation of Capacitor in 325 AD.
WTAM.com. We're with you wherever, with all the latest events. Just tell your smart device to play WTAM 1100 on iHeartRadio.
Cleveland's news talk from the Cleveland Ford Lincoln Studios.
Featuring the 2022 Ford F-150. Become the extent.
They're not accountable to you and me. They're beyond the reach of government and citizens, and yet they hold the fate of the global financial system in their hands. To get a sense of how they operate, imagine an array of floating spheres. One sphere is labeled IMF, one is labeled Fed, one is labeled Bilderberg, one is labeled Wall Street. One is labeled central banks. One is labeled intelligence agencies. One is labeled media, and so on.
Okay.
The elites inhabit all of these
Time for
spheres.
some Howard's
And
action.
together the network forms a kind of 3D Venn diagram. As I see it, regardless of what sphere they inhabit, the elites all share the same vision. One world order, one world taxation, and one world order,
Neutral.
one world taxation, and one world money. A short list will include Managing Director of the International Monetary Fund, IMF. Mark Carney, Governor of the Bank of England. Raghuram G. Rajan, Vice Chairman of the Bank for International Settlements. Haruhiko Kuroda, Governor of the Bank of Japan. William C. Dudley, President of the Federal Reserve Bank of New York. Agustin Carstens, Governor of the Bank of Mexico. Janet Yellen, Chairman of the Board of the Federal Reserve System. Mario Draghi, President of the European Central Bank. Xu Min, former Deputy Managing Director of the IMF. Zhou Zhuquan, Governor of the People's Bank of China. Robert E. Rubin, Chairman of the Council on Foreign Relations. This A-list of central bankers and other elites is just the tip of the iceberg. Of course, not one of these elites will tell you outright what's going on, but I've seen and heard enough to connect the dots for myself. Not long ago, for example, I met with one of their senior operatives. He's a leading economist who served as the chairman of the Federal Reserve during the last crisis. He's considered one of the most influential minds in banking today. We met privately during a conclave in Seoul, South Korea. Of course, I'm talking about Ben Bernanke. I came away from my meeting with him stunned and convinced that ICE-9 was real. Not long before that, I set up a one-on-one meeting with another member of the network. His name is Xu Min, the former deputy governor of China's central bank. Until recently, he served as deputy managing director of the International Monetary Fund. Xu is a brilliant guy, like Bernanke, and he's pleasant and well-meaning. There's no doubt in my mind that he's also a member of the elite network preparing to impose ICE-9 on millions of Americans. But I wasn't done with my research. I have since met with dozens of senior officials, intelligence analysts, and former Wall Street colleagues. My quest led to a final meeting, a face-to-face summit with the head of Bilderberg. We met at Rockefeller Center in Manhattan, and he was very eager to get my take on the euro as a currency. I was happy to provide it, of course, in exchange for some valuable intelligence. As I say in my new book, he did not have horns. In fact, he gave me a nice gift when we parted ways, a blue Swedish vase. I keep it in my writing studio at my home in Connecticut. But my point is, I came away from all three meetings convinced of one thing. When the next crisis hits, the elites are planning to freeze the financial system, and they'll replace it with a new system, one not based on the U.S. dollar. When that happens, we'll wake up to a very strange and disturbing new reality. And for
There it is, running off of my AM transmitter. This is the ground lead clip. This is the antenna lead here. All polished up and spruced up. There. this video, please like and subscribe for more antique radio content. Thanks for watching.
It's smooth sailing with the highly successful sound of wonderful